Hello, hello. As you can tell, my name is Namik. I'm here to talk to you a little bit about what the fuck is real-time DePIN? How can these two things be connected? Now, I'll be honest, part of it is just me talking about what MegaETH is and how it can enable an entire new design space for DePIN products. So I think if there's one thing you can take away from this conversation is that we are making extreme design decisions for how one can actually scale a network, right? And we are very much performance first in our philosophy. A little bit about our team. So our team has pretty strong domain expertise in low latency computation, high throughput networks, and just a general spirit and technology behind blockchains. Why are we actually truly here today? Elong studied low latency computation at Stanford for his PhD. Lei did high throughput blockchains at MIT for his PhD. For those of you in the know, he's actually one of the authors of the famous DA white paper alongside Shuyao from Eigenlayer. Shuyao led global business development and consensus for 6 years, touching on MetaMask, Linea, and Infura. And myself, I'm just like the neighborhood crypto degen, right? There are a lot of stuff in venture, investing in infrastructure companies, did some liquid trading at a prop shop, and I've been an operator ranging from DAOs to companies like Consensus. Oh, okay, you guys can see the screens. So fundamentally, we have a thesis, and it's a thesis that you've heard before. It's that layer ones don't necessarily actually have the ability to scale compared to the world compute, right? And a lot of people have said this, but I think for us, we fundamentally believe that there is a massive trade-off between performance and decentralization. Truth be told, the more performant you want to be, the more beefy your nodes have to look, right? And this is visible in the landscape today. Ethereum is extremely decentralized, but it's not very performant. Solana, it's a bit less decentralized, but a lot more performant, right? And I think the best way to look at this is via this analogy, right? Imagine you are a high school teacher. You have 1,000 students in your class. The smartest kids are really sharp. They can pick up information very quickly. But because you have 1,000 students, you have to go at the pace of your slowest child. And because of that, you can never really go as quickly as you want to. That's what blockchains look like today. Blockchains throttle themselves so the slowest participant is not dropped. That's called the straggler problem, and it's innate to all layer ones, right? Now, that doesn't mean you can't do optimizations on the layer one. So teams like Monad are working on optimizing the EVM. However, for us, the North Star is proportional scale to the world compute. And our belief is no layer one can sufficiently scale to that level of demand. So what does MegaETH do? All right? For us, we look at ourselves as a last mile solution for scaling. And that means execution. We believe that the layer one and the layer two should have a division of labor, right? Layer one focuses on decentralization, security, while we can focus on creating the most performant environment possible. And that's exactly what we do. So first thing we do is something called node specialization. Node specialization is the process of making nodes heterogeneous, meaning that each node does something different. That's very different than the traditional blockchain architecture, in which each node does the same thing. So why is this interesting, right? Well, the blockchain has a variety of tasks it has to solve. There's execution, there's sequencing, and there's validation. Our approach is, hey, well, what if we hyper-optimize the node for that particular task? So execution, why not have a single node do execution and have as many nodes possible to do validation? That now allows us to create specialized hardware for the function of that task. Meaning we can have a very, very beefy sequencer, so we can produce a lot of blocks while having an extremely lightweight prover architecture, right? So as many people can validate the network as possible. The end result is what we've actually built, right? Which is a hyper-optimized block production mechanism. Quickly want to show you the difference between our nodes and other nodes, right? So as you can see, the sequencer is effectively the node that does block production. And that is extremely beefy, magnitudes more beefy than Solana. It allows us to have 100,000 transactions per second and 1 millisecond latency / 1 millisecond block time. At the same time, if you look at our validator nodes, they're extremely lightweight, much more so than Ethereum, which is the most decentralized layer one. So in some ways, we are actually the most decentralized validation architecture out there. This is supposed to be another slide, obviously. But basically, what's the outcome we're at right now? The sequencer is extremely beefy, meaning that we have very, very successful block production. Now, it's good to have one highly performant piece of the puzzle, but the second we have, this one piece of the puzzle that's optimized, bottlenecks will show up across the rest of the stack. So what we need to do is we need to look at the entire system and create additional optimizations to be able to match the performance that we have. Here is a basic visual of the MegaETH architecture. So we have this sequencer, as I mentioned. It's a high-end server, magnitudes more so than the nodes you'll see on Solana. And effectively, because of this level of performance, we're able to do additional optimizations. We're able to do things like in-memory computing, JIT compiling, as well as something called parallelization. Now, we have another component, which is a prover network. Traditionally, a prover network has looked a lot like the sequencer, right? But what we do is we effectively have our prover network. Each prover node will do a subset of the sequencer's transactions. That's similar to something to this validation. Long story short, it means that our provers can be extremely lightweight, while the sequencer is very, very powerful. Now, a prover network will then push the proofs to the full node, right? The full node is the second point in which there's going to be additional optimizations needed. Firstly, one of the core functions of a full node is to maintain state, right? The state trie. That has been a traditional problem for full nodes, and even more so an issue on MegaETH, because we are so performant. What we've done is we've rewritten the state trie. Secondly, the state diffs / state deltas, which are pushed from effectively the sequencer to MegaETH, are compressed. So you're able to create a very, very smooth flow. We also use EigenDA. So what's the outcome here? We have a blockchain that's 100,000 transactions per second. We have sub-millisecond latency and 1 millisecond block times. That opens up a completely new design space of what kind of applications can exist. And that's exactly what I'm here for today. Before I move on to DePIN, I want to quickly touch on, well, is this like super centralized? Is this super problematic? X, Y, and Z. I think this is like a very crucial unlock that we need to discuss for what a layer 2 can do. We are not here to replicate the layer 1. The layer 2, by building a layer 2, we are able to do a variety of things. A, we can use proofs to ensure that the sequencer is following these rules. Initially, we'll be using an optimistic architecture, but as ZK costs go down, we'll be able to very easily switch into a ZK architecture instead. Secondly, we basically enable the guaranteed rights of a user to force exit, right? They're able to leave if they want to. Finally, users will have the freedom of choice to be able to choose a sequencer. When we think about the decentralization of sequencers, we think that's quite problematic. Because the second you decentralize a sequencer, you end up bringing all of these latency issues and all of these throughput issues, which fundamentally do not scale a blockchain, which is what the layer 2 is here to do. Instead, we are going to allow users to be able to choose and rotate the sequencer, even though the sequencer itself is beefy. How does this impact DePIN, right? I think that there are 3 main design spaces I'm particularly excited about. A, the ability to have extremely low, very low latency data processing, fully on-chain. Secondly, you can really scale up the frequency of data collection and transmission. And then finally, we have scalable microtransactions on-chain. For some of my favorite examples, what does this look like? It can look like a near instantaneous processing of data and rewards. It can look, but if it's 5-mapper, it can look like the real-time uploading and integration of mapping data and faster transaction speeds to the contributors. I always think, why would you not rather get paid real-time for contributing to the Hive-mapper map? If you can do this all on-chain, it can be priced properly on-chain. Finally, if you're doing like an Uber product similar to Dymo, higher frequency of data uploads while remaining fully on-chain. Yeah, so a bit about how we're approaching ecosystem development. We think that fundamentally MegaETH is a massive unlock, right? Things can be built now that could have never been built before. Things that brought you into crypto, that made you excited about crypto, can actually now be built. So we're in the process of finding teams, hopefully some of you, and we want to work very close with you in exploring the MegaETH unlock. I have some ideas. Our team has some ideas. I'm sure you have better ideas about how to build really cool products with DePIN on MegaETH. So after this presentation, please join us. We're trying to make Ethereum great again and have a very good time while doing it.